System selection plays an important role to determine the outcome of your architectural glass feature. Today I'm going to show you a glass canopy with unwanted sagging members. This is not only because of the wrong system selection but also the wrong material selection. Before we go on, please note carefully that the purpose of doing this video is to point out some areas that need a great care of consideration when you select and design architectural glass system, and hoping to see the upcoming glass feature around the world with more and more success. The glass canopy that we are gonna talk about is the entrance to the underground area. High transparency of the structural glass system provides a great amount of daylight to the exit for people down below. The glass structure is mainly supported by the main building on the right and a standalone wall on the left. This is the building and the standalone wall in close-up. This diagram shows the context of the canopy. Let's have a look at the sagging members and then I'll show you how it happens. This glass canopy is considered as structural glass facade, which is a combination of glazing system and exposed structural system, not just a spider glazing system. So we should stay away from those who are specialized in only aluminum and glass. The selected structural system is planar or flat cable net system with additional of cables in another direction. So instead of having two ways of cable helping each other like conventional cable net system, there are three, which should be better, but why it usually fails. Let me give you an idea of what the cable net system is. Cable net system is the use of tensioned cables oriented in two directions. With sufficient pre-stress forces, the cable will form a structural system that can support the glass and control deflection in the same time. Required tension forces are substantially higher than those of cable truss system. It is even higher when it comes to the one-directional cable system, or as people call, cable mullion system. The fact that the cable net system requires high pre-stress force impacts the boundary structure significantly. The boundary structure has to be sufficient to take the high pre-tension force. It's even more challenging with a system that is not vertically glazed like skylight or canopies. Looking at the site condition, we have the building and the wall, which I believe it is dedicated for this entrance. The building is physically possible to accommodate the high tension force, as the reinforcement can be added to the beam. But it is very challenging for the standalone wall to have structurally sufficient anchor points at the top level of it to accommodate the tension horizontal cables. You can see here that the boundary structure has to take the same amount of the pre-tension force applied to the cables. In case that the tension force is too high, we can expect this kind of thing happen. In worst case of practice, we might think about reducing the pretension force to be in the range that the main structure can achieve. Then what we're gonna have is incomplete cable net system, and of course we will see some member sags. This diagram shows how different facade systems interact to the main structure. The blue arrows on the right are how normal glass systems act to the boundary structure. The red arrows are how cable system will act to the given condition. And the fixing of this anchor point doesn't look sufficient for anchor point of the cable net system, so I don't think that the cable is tensioned properly to the requirement of the cable net system. By the way, the detailing and craftsmanship of the fitting and accessories are very nice. However, this won't help in terms of structure. The use of diagonal cable is very smart. It can reduce the length of the cables needed. Diagram on the right, if we use conventional cable nets, the length of the cable will be quite long. You can see the red line on the right. It's shorter than the blue line if we use the conventional cable net. And it will impact the tension force and cable sizing as well by using a longer cable. Diagonal cable arrangement is a good help for this opening. But since it was wrong system selection since the beginning, so the final outcome cannot be good. However, up until now you should be able to notice that the linear members used here are not the cable. In facade industry, cable is linear material made of strands. It is used in application with long and continuous members. It is the major material for the cable net system. There is always confusion between cable and rod when it comes to the tension structure. Appearance-wise, cable has texture of strands, while the rod is smooth in surface. Cable is installed by pre-tensioning to the required force as per engineering calculation in order to perform as structure, while tension rod is used and installed differently. This is a picture of cables installed at ear plate waiting for pre-tensioning. You can see that they are not even in a straight line yet. In this picture, the cable is used as cable truss system to withstand the wind load, while the rod is used to support glass dead load. You can see the texture of the strand at the cable truss, but the rod which is supporting the dead load is smooth in surface. Let's get back to the cable net canopy. The structural system we have here is not a proper structure in terms of insufficient tension forces due to insufficient boundary structure. and the use of tension rod instead of actual cable. This makes transverse rods sag due to the gravity. The gravity works 24/7 even though it's not shown in the drawings. This is an example of cable net skylight glazing that is done properly by having a sufficient boundary steel structure that was engineered for the tension forces since the beginning. We cannot deny the fact that main structure is in condition that is more suitable to take load vertically. But what if we really want to have a cable net system? What can we do? We can have a closed system of cable net, which is the cable net system with its own boundary structure. So the whole thing becomes a separated element. And then we can lay it on the main structure in the way that it can work properly. This diagram is conventional cable net system. It's an open system. Please disregard the cable orientation in this diagram, which is not similar to the canopy, but the concept is the same. Being an open system means that the pretension forces required in the cables, which is the blue arrows, will cause the reaction forces from the boundary in the same amount, which is the red arrows. For this canopy, the boundary is the building on the right, the freestanding wall on the left, and the steel beam at the front and the back, which are connected back to the building and the wall. What if we create a cable net system that is closed system by having perimeter steel at 4 sides? The steel will take high pretension loads of the cables, but I'm not sure how big is it that we need, and is it aesthetically okay or not. Once we have this cable net as a separated system, we can lay this whole piece of structure on the building and the standalone wall and let them take care of the cable net system vertically. That's all for this episode. As you can realize that some part of this episode is actually my assumption, but I believe that even my assumptions are all wrong. But the other part that is about the cable net system can still be useful for you. So if it is so, please help sharing it. Thank you and see you next time.